You guys, here we are in our fifth week of online learning. I mean, it is crazy to me that we have 4 weeks of this already under our belts, and really, we just have 4 weeks of eighth grade left to go. There's a part of me that's excited that we only have 4 weeks left because let's be real, this is way more exhausting than just regular teaching, and I miss getting to see you guys in person. But the other part of me is really sad because the high school gets you next year, and I don't. I do want to say to you guys who are watching this, I am so proud of the fact that you are checked into what we're doing. And really, there's not another group of students that I'd rather be navigating this online learning business with. I mean, you guys have had to learn an entire new way of being students. You guys have helped each other out, you've helped teachers out, you've reached out when you've had questions, when you don't understand things. And those of you who have really stuck with this, I mean, you all are troopers, and I'm just so proud to be able to say that you're my kiddos. Hopping into our learning this week, let's just recap for a second. So, last week, we left off with this tsunami, and it's this tidal wave that's approaching the shore. And you all told me that once it reaches the shore and starts running into the side of the continent, the only way for that wave to go is up. I mean, the wave slows down, sure, but the energy that originally went into its speed is now causing that tsunami to get way big and tall. Let's head back to the epicenter just for a day though. You all told me that the wave is traveling out from the epicenter. And if your brain works anything like mine, you get to wondering, if that wave is traveling out, then how on earth does there not end up being this hole where the tsunami started, right? Where the wave used to be? And then you get to wondering, I mean, what exactly is a tsunami? Like, sure, it's a tidal wave, and sure, it causes a whole lot of destruction, but how exactly does that tsunami act when it's on open water? We're going to do some experimenting with waves today to figure out what is going on. But before we do that, you're going to need to set up your ISN. So I want you to pause the video and I want you to pop on a song and go ahead and make sure that your notebook is set before we launch into our experiment. Now, for your experiment, you're going to need, first of all, your ISN because your points today are from writing down your discoveries based on what you see in your different trials. You're also going to want a jump rope or a regular rope or an extension cord or even a hose, or you could experiment with different kinds of ropes. Something about stomach high to tie your rope to, and that'll be our fixed point. You need a long space that's free from obstacles. And it would be really helpful to have a slow-mo camera on your phone or even just a regular video camera capability. Maybe you could even use your Chromebook. First, you want to tie your rope to a fixed point. Make sure that knot is pretty secure, but not so tight you can't get it undone afterwards. Then you're going to step back and move your hand straight up and down in what we call an oscillating motion. Oscillating means that you're moving back and forth at a consistent speed. Once you feel like you've got that motion down, go ahead and start working through your what happens when trials. Once you have all of your trials and observations, come back and I have one video to show you. There are some marked points on my rope in this video where I had to knot the ends of jump ropes because it wasn't long enough for what I wanted to see. But you're going to fill out in your ISN what exactly is happening with these marked points. How are they moving? I want you to fill in the blanks. Marked points on the rope are moving up and down, side to side. They are not moving up and down, side to side. All day, you have seen that the rope wave that we're observing is really energy that's traveling through that rope horizontally. It's not the rope itself moving horizontally. So at the very end of your notes, you have one last question to answer. If a tsunami is a wave, why is there not a huge hole in the ocean water where that tsunami started? As soon as you have that, go ahead and snap a picture of your notes and get it submitted to me, and you are done-zo for the day. Hey, I hope you have a great rest of your day, and I'm looking forward to seeing you guys on Zoom on Wednesday. All right, love you people.